In this video, the focus is all on the winds. Looking at the globe, we have it separated at the equator, then 30 degrees north and south, then 60, and then 90 degrees at each pole. First, it is important to show what the pressure is like at the surface in each of these areas. The H in green is for high pressure, and the L in red is for low pressure. At the poles, the surface pressure is high and the air is cold and dry. Cool air is descending to lower surface pressure. Same for the 30 degrees north and south. Remember, surface pressure always moves from high to low, and high pressure air is dry and cool. Next, let's look at the 4 different kinds of winds. To start, we will look at the polar easterlies. Polar easterlies have cold air subsiding at the poles, creating the high pressure, forcing an outflow of air towards the equator. That outflow is then deflected westward by the Coriolis effect. Unlike the westerlies, which we will discuss next, which reside in the middle latitudes, the polar easterlies are often weak and irregular. These prevailing winds blow from the east to the west. Now for the westerlies, also known as prevailing westerlies, are prevailing winds from the west toward the east in the middle latitudes, between 30 and 60 degrees latitude. The westerlies are strongest in the western hemisphere and at times when the pressure is lower over the poles, while they are weakest in the southern hemisphere and when pressures are higher over the poles. The westerlies are particularly strong, especially in the southern hemisphere, where there is less land in the middle southern latitudes to cause the flow pattern to amplify, or become more north-south oriented, which would slow the westerlies. Next are the north and southeast trade winds. The trade winds blow predominantly from the northeast in the northern hemisphere, and from the southeast in the southern hemisphere, strengthening during the winter and when the Arctic oscillation is in its warm phase. Historically, the trade winds have been used by captains of sailing ships to cross the world's oceans for centuries and enabled European empire expansion into the Americas and trade routes to become established across the Atlantic and Pacific Oceans. In the 30 to 60 degrees south, we have westerlies again, and 60 to 90 degrees south are the polar easterlies again. Now let's look at the cells that form from these winds. First is the polar cell. Though cool and dry relative to equatorial air masses at the 60th parallel are still sufficiently warm and moist to undergo convection and drive a thermal loop. Air circulates within the troposphere, limited vertically by the troposphere pause at 8 kilometers. Warm air rises at lower latitudes and moves poleward through the upper troposphere at both the north and south poles. When the air reaches the polar areas, it has cooled considerably and descends as a cold, dry, high-pressure area, moving away from the pole along the surface, but veering westward as a result to the Coriolis effect, to produce the polar easterlies. Next is the Ferrel cell, which circulates between 30 and 60 degrees north and 30 and 60 degrees south, theorized by William Ferrel. It is a secondary circulation feature, dependent for its existence upon the Hadley cell and the polar cell. It behaves much as an atmospheric ball bearing between the Hadley cell and the polar cell, and comes about as a result of the eddy circulations of the mid-latitudes. For this reason, it is sometimes known as the zone of mixing. At its southern extent, in the northern hemisphere, it overrides the Hadley cell, and at its northern extent, it overrides the polar cell. Just as the trade winds can be found below the Hadley cell, the westerlies can be found beneath the Ferrel cell. Lastly is the Hadley cell, which circulates between the equator and 30 degrees north and south. The Hadley cell, found by George Hadley, is a closed circulation loop, which begins at the equator with warm, moist air lifted aloft in equatorial low-pressure areas to the tropospause and carried poleward. At about 30 degrees north-south latitude, it descends in a high-pressure area. Some of the descending air travels equatorial along the surface, closing the loop of the Hadley cell and creating the trade winds. Though the Hadley cell is described as lying on the equator, it is more accurate to describe it as following the sun's zenith point, or what is termed the thermal equator, which undergoes a semi-annual north-south migration. The Hadley system provides an example of a thermally direct circulation. Thank you for listening and hope you learned a bit about the wind and the wind cells. My voice